Okay, students, last lesson of topic 3, lesson 3 of mod 1, page 185. I want you to do the warm-ups at the bottom of the page. Go ahead and do these. Find the unknown angle measure. So hit pause, find your answer, and then hit play to see if you got them right. Again, this is something you can do with any of these problems that I go through. If you want to go through them again at the beginning of the problem, hit pause, work it out yourself, and then hit play to see if you really know the material or not. Okay, so you should have already finished 1 through 3. We know all triangles add to 180, called the triangle sum theorem. So here we have 108, 115 from 180. So that's 65. Here we have 146 from 180. That's 34. And here we have 63 from 180. That's 117. There's your answers. Go to page 187 now. 2 more pages. Okay, so now we're going to use SSS, SAS, or SAS and ASA that we just did in our last section. Okay, do number 1. Reflexive property. Here's one that is a major one you're going to use in proofs, so you need to know what it says. It says A equals A. You can use the reflexive property with an angle or a side length. So here we have angle A equals or is congruent to angle A, or segment AB is congruent to segment AB. So it can be with angles or sides that are equal to itself. So suppose AD bisects angle A, so that means it splits in half. So we have those right there, and AD is perpendicular right there. Are the two triangles in this diagram congruent? Well, notice I have this side that's in common from both triangles. That AD is in both triangles, so I can say segment AD is congruent to segment AD, AD, by reflexive property, which is what we just read off right there. Okay, so now do I have enough? Remember, these are our 3 ways of proving triangles congruent. Do I have SSS? No. Do I have SAS? No, I don't have 2 sides of an angle. I have ASA, angle, side, angle. So yes, by ASA. Okay, now go to page 190. Okay, now we're looking at in the coordinate plane. Everything on the DCAS in the coordinate plane. So we're going to do number 2. How do we show these 2 triangles are congruent by SSS? I have to find the side length of each of the 6 sides, 3 in each triangle, and they should be the same correspondingly. So again, how do I find the side length? I use Pythagorean theorem. 1, 2, 3, 4. 1, 2, 3, 4. So this ends up being 4 root 2, or the square root of 32. Okay, well, if I do that same thing here, I have 4 and a 4, so that's 4 root 2, or square root of 32. Okay, I draw, we'll change the color for another one. Draw this right triangle. 2 and 1, 2, 3, 4, 5, 6, 7. 49 and 4 is square root of 53. Okay, we do that one here. 1, 2, and 1, 2, 3, 4, 5, 6, 7. See, 7 and 2 again, so square root of 53. And lastly, go to green here. 1, 2, 3, 4, 5. 1, 2, 3. Right there. And notice here I have 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Do we have 6 here? 1, 2, 3, 4, 5, 6. Okay, so it's 6. So we get 3 and 6. So again, with Pythagorean theorem, we get 36 and 9 is square root of 45, or 3 root 5 if you simplified it. So this is what you would need to show. Okay, this would be in a box, so you'd end up saying, name the sides. So what is that? ST equals the square root of 45, which is same as JK. Okay, and then I have KL equals 4 root 2 or square root of 32, which also equals RT. And then I would say JL equals square root of 53, which is the same length as RS. Okay, so this is something like this is what you would type in your box. You actually have to calculate out the length of each side. All right, go to page 192 now. So it's 2 pages ahead. And we're going to do number 4 here. How you can prove it is congruent by SAS here. Well, I can see right here I have a perpendicular because I have a horizontal and vertical. So I'd explain that horizontal and vertical create a perpendicular or right angle. So there's my A for the side angle side. Okay, there's your A. There's your A for side angle side. Okay, so now we're going to show that this side, which is 1, 4 there, and 1, 2, 3, 1, 2, 3, 4, 5. I count right? 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, these are not congruent. Okay. So these are not congruent. They probably were supposed to be. They miscounted because that's 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5, 6. And this is 1, 2, 3, 4, 5, 6. Okay. And that's only 4. 1, 2, 3, 4. It's supposed to be 5. So there's an error in this one. But so if I have horizontal, it should have been a 5 right there. And now I have S, A, and S. And this would be S, A, and S for SAS. Okay. Okay, do this page and the next. That'll end it here. Okay. State the theorem that proves the triangles are congruent, then write a congruent statement. Okay. So notice I have A, S, A. There's A, S, A. So I need their SAS. I'm sorry, ASA. We just wrote it down. That's why they're congruents. Then I name the triangles in corresponding order. It doesn't matter if I call it ABE for the first one. It doesn't matter where I call the first one, but the second one must go in corresponding order to how I name that first one. So this is I went A for the right angle. I have to go C for the right angle here. I went to B, so I have to go to B there, and then E corresponds with D. So that right there is called a congruence statement. Okay, so then write a congruent statement. That's what that piece is. State the theorem. That's this piece, ASA. Okay, here, notice we have a side in common. So that's my side. So I have ASA, ASA. So ASA is my theorem. Okay, now I have to go ahead and write my congruent statement. Again, you should have hit pause already and do this yourself, and then hit play and check it. So if I go HMT, H corresponds with A, M corresponds with T, and then M. Corresponding order. Okay. Again, hit pause on these and then try them yourself and then check them. So here I have SSS. Okay, triangle MLN is congruent to triangle PNL. Okay, so I have to go in the same order. I went from here to here along the 1. So here to here along the 1 piece and then across. Okay, here I should recognize vertical angle theorem. So now I have S, A, and S. So SAS is my theorem why the two triangles are congruent, and write out my congruent statement. ABC is congruent to triangle EDC. Okay. And so that's this page. Let's do the next page to finish it off. Determine if the information, or determine the information that is needed to use the indicated theorem to show that triangles are congruent. So they want the two triangles to be congruent by SAS. Notice I have A right there. I have my reflexive property when I get free on my own, reflexive property. So I have SA, so now the other one has to be S right there for SAS. So the information I need is that F segment FJ is congruent to HJ. That's what's needed, okay, to prove them congruent by SAS. I get a free point here with vertical angle theorem, and it wants an ASA. So AS, here's my other A then, ASA. So I need angle W is congruent to angle Y. Now I have ASA. You usually have one of these on the DCAST as well. They want it to be SAS. Well, there's my S, so here's my other S. So segment JK must be congruent to TK, segment TK. They want it by ASA. Well, I get my free point of reflexive property right there, so I have AS and A right here. So I need to say angle DFE is congruent to angle DFG. Okay. I can also use DFE, so DFG, same order up there. Okay. And that will do it. Work on Matthew now.